Okay, we're in 2.3a. This will probably have a couple videos since it's like 400 pages long in this section. College Algebra, page number 200, quadratic equations, functions, and models. Alright, so you're used to a quadratic equation looking like ax squared plus bx plus c equals 0. And a quadratic function looks the same way, only it's ax squared plus bx plus c equals f of x, my function of x or my y. And when I make my f of x 0, then I find out where my x crosses, or my answer is where my graph crosses the x-axis, because if my y is 0, it didn't go up or down any. This is standard form right there, my ax squared plus bx plus c equals 0. And it says on the bottom of page 200, which you've already heard me say over and over, the zeros of a quadratic function, which we're looking at right here, the zeros of a quadratic function are the solutions of the associated quadratic equation, ax squared plus bx plus c. These solutions are sometimes called roots of an equation, and I've mentioned that before. And they can have real number or imaginary number zeros. So if the zeros or solutions are real numbers, they are also the first coordinates of the x-intercepts of the graph of the quadratic function. Alright, so we've already talked about all of that. It may sound like mathanese, and you're like, I don't remember ever talking about that. You did, or we did. It just may not sound the same coming out of the book as it does coming out of my mouth. But they give us our first example of 2x squared minus x equals 3, and we put it in standard form so that we can solve it. And we set it equal to 0 because, again, we're looking at where the graph crosses the x-axis. So we go ahead and do the math in this, and we get x plus 1 and 2x minus 3, and that equals 0. So x equals -1 or x equals 3 over 2. And what that means is if we were to graph that, my graph is going to go something like this. So there's my -1, and there's my 1.5 or my 3/2. So my answer is where this parabola crosses the x-axis or the x-intercepts. So if you were to look at example 2, exact same thing. You're getting two values for x, a square root of 5 and a negative square root of 5. When you solve for 2x squared minus 10 equals 0, you get a parabola, and you can see in the example on page 202, right-hand side of the page, what happens when they graph that equation. Okay, so if you continue on, let's say the example on top of page 203, they give us x squared minus 6x plus 9 equals 0. They solve this, and they get x minus 3 times x minus, okay, let's get rid of that, x minus 3. So my x value is 3 for one, 3 for the other, and that means when I graph it, I get a parabola whose vertex is on the x-axis right there. So that's why they only got 1 point there. Okay, so bottom of page 203, talk about completing the square. So let's jump to example 3 on page 204. So again, this should be basically a review. I'm just going to rewrite this. And I'm going to set it equal to 0. So that I'm looking for the answer for x, so then I have to set my y value to 0. And I'm going to move the 10 over. And I'm going to take half of 6 and square it. Add it to both sides. Then I am going to take the square root of the x, the square root of the 9, put this sign here, square it, and make it equal to 19. I am going to take the square root of both sides, and I get x minus 3 equals plus or minus square root of 19. I'm going to add 3 to both sides. And so my x value is both 3 square root of 19 and 3 minus square root of 19. Okay, little bit more difficult to graph something like that. So when you are graphing it, you've got 3 plus the square root of 19. Well, I know that the square root of 19 is going to be somewhere between 4 and 5. So let's just take 4 plus 3 is 7. So it's going to cross somewhere a little bigger than 7. And then a little 3 minus 4-ish. So it's going to be just kind of like between 1 and 2 there. So it gives me it tells me a little bit of an idea of what that's going to look like. Okay? So that's kind of helpful to be able to take the square root of a number and add it to the 3 or subtract it from the 3 and be able to get an idea of what your x values are.